All right, welcome to Unit 5, Sampling Distributions. In this video, we're going to talk about Topic 5.2, the normal distribution revisited. Please keep in mind that this is Part 3 of Topic 5.2. So if you haven't watched 5.2 Part 1 or Part 2, please go back and watch them. So we've learned all about the normal model and how we could find probabilities of intervals, how we could actually find intervals with a given probability, how we can determine if something is significant or not based on the probability. Well, there's yet another important aspect that comes out of it, and that is combining continuous random variables together. Okay, so recall combining is either repeating a single random variable multiple times or combining two or more different random variables together. If the random variable or random variables follow a normal distribution, then once you combine them, the sum or the difference of them will still follow a normal distribution. This allows us to find probabilities of the sum or difference of random variables. So please keep in mind when we're talking about combining random variables here, we're really focusing on doing one random variable multiple times. Like for example, if Josh were to wash 5 cars. Well, we could combine the total lengths for those 5 cars. Then since the length for 1 car follows a normal distribution, then the length of the sum of 5 cars will also follow a normal distribution. We could also look at the difference between 2 random variables or the sum of 2 different random variables. For example, maybe Josh is going to wash and wax cars. Well, if they both follow normal distribution, when you look at them together, or if you look at the difference between them, you're still going to follow a normal distribution. So keep in mind how you must approach combining standard deviations. That's the one trick. Remember, you're not allowed to add standard deviations. You have to add variance first. So keep that in mind, and we'll review that as we watch this video. All right, so here's a good example. All right, Tom and George both love to bowl. In fact, they've bowled so many times that they know their mean and standard deviation. Tom's games follow a normal distribution with a mean of 190, standard deviation of 8. If you know anything about bowling, that's not bad. George's games follow a normal distribution, with a mean of 210 and a standard deviation of 15. So what we get from this information is that George is a slightly better bowler, on average 20 pins better, but he also deviates a little bit more. So he has the likelihood of some better games, but he also has the likelihood of some worse games. So the question here is, if they bowl a game, what is the probability that their total score is more than 430? So we're trying to find the probability that their total score is more than 430. So if I'm trying to find a probability, a couple things are popping into my mind. I need normal CDF, right? To find normal CDF, I need z-scores, but I can't do any of that yet because I first have to think about the total. Because this question is not just about George or Tom, it's about both of them. So to find the mean of their total, I'm simply going to say, to find the mean, I'm going to say, well, listen, Tom is an average of 190 plus George is an average of 210. Well, just add those together, right? So grab your calculator if you need to, unless you can do it in your head. 190 plus 210. I'm expecting them to have a total of 400, okay? That's pretty easy. So when we're finding the z-score for 430, we need the mean. Okay, so let me write that down. We now know the mean is 400. That's the mean of the total, adding them together. Okay, awesome. But, oh boy, standard deviation, please, it's a little bit trickier. We're not allowed to simply add 8 plus 15. Nope, not allowed to add standard deviations. But you are allowed to add variance. And remember, variance is nothing more than standard deviation squared. So if I take 8 squared, I get the variance for Tom. And if I take 15 squared, I get the variance for George. Now, I am allowed to add those together and then a giant square root around all of that variance to get back to standard deviation. Just keep in mind that standard deviation squared equals variance. Therefore, the square root of variance equals standard deviation. All right, so what I have to do on my calculator is I have to do the square root of 8 squared plus 15 squared. That's all of my variance, and I get 17. Pretty nice number. Doesn't always work out to be such a nice whole number, but it did here. All right, so now I'm ready to answer the question. All I need is my z-score. What is, how likely, or how far from the mean is 430? So I'm going to take 430, the number I was asked about, and subtract the mean, divide by the standard deviation. So that's simple, right? Nice and easy, nothing hard here. So 430 minus 400, and then divide by 17 is 1.7647. 1.7647. All right, so the question asked me to find the probability that their total is greater than 430, which is equivalent to find the probability that a z-score is greater than 1.7647. And the answer to that is going to be found by using normal CDF on my calculator. I'm going to go from a lower value of 1.7647. I'm going to go all the way towards infinity because I want to go all the way more. And I'm going to use a standard mean of 0 and a standard deviation of 1. And again, that's what my calculator is going to do, but I'm trying to make sure I show you guys all the work that must be shown if you want full credit. All right, so here we go. So I'm going to start at 1.7647. I'm going to go to 99. Remember, I do not have an infinity button on my calculator, so I'm just going to use infinity, or as 99 as my infinity. And I get a probability of 0.0388. 0.0388. So, another question I could ask you is, would you be surprised? Would this be significant if they were to have a total of 430? Well, if you're going to go with significant as 1% or less, then this would actually not be significant. This would be, on the unlikely side of things. It would be, 4% is kind of low, but it's not that significant. Now, if you were to change your mind and say that under 5% is what you consider to be significant, well, then this total would be pretty significant for George and Tom to do. But, I like to personally go with 1%. But again, in that case, this would not be significant. But that wasn't asked you. The question just wanted you to find. So again, all I had to do was think about finding the total, the mean, which is pretty easy, 400, and the standard deviation is the only tricky part there. But after that, it's just as easy as the other questions we've been doing. All right, let's do one more example here dealing with our friends Tom and George. Once again, they both bowl. They both have a mean, they both have a standard deviation, they both follow a normal model, which is awesome, but this time the question's a little different. If they each bowl a game, what is the probability that Tom scores better than George? So in this case, I'm looking at the difference. And I know that George minus Tom, typically, on average, that difference is 20, right? Once again, how did I get that? Well, George typically bowls at 210. Tom typically bowls at 190. That's a difference of 20. So on average, I would expect George to be 20 more pins than Tom. But think about it. George could deviate on the low end. Tom could deviate on the high end. And all of a sudden, maybe Tom does score better. So it is possible. And the question is, what's the probability of that happening? Well, before I move any further, now that I understand that the average difference is 20, I now have to find the standard deviation for the difference. And this is another important rule that I hope you remember from last unit on combining random variables. I'm not allowed to add or subtract their standard deviations. Not allowed to do that. But I am allowed to add their variances. Now, even though this problem is looking at the difference between George and Tom, George minus Tom, you always add variance. The fact that I'm putting these two bowlers together, the fact that Tom and George are both bowling. Now, I'm not looking at the total anymore like I did in the last question. I'm looking at the difference. But the fact remains they're both bowling a game. So the variance between them will always build up. It'll never diminish. So this is going to be the exact same 17 that we got on the previous problem. All right, so now I understand the difference. I understand the average is supposed to be 20, but that average could deviate by 17. Now I have to figure out how to answer this question, and that's the tricky part. Here's the trick. I need to focus on 0. Here's why. Because if George does better than Tom, when you subtract George minus T, you will get a positive number. If George is bigger, if George does better, you're going to get a positive number. If they are tied, if George and Tom both are equal, they both bowl the same score, you're going to get a 0. But if Tom does better, if Tom's score is higher than George's, you will get a negative result. And this is the scenario I'm looking for. I'm not looking for a positive result because that's when George does better. I'm looking for a negative result when Tom does better. And that means I need to focus on 0 because a score of 0 is the cutoff between positive, George does better, and negative, Tom does better. So what I need to do is I need to find the z-score for 0. I need to subtract 20, that's the difference I expect, divided by the standard deviation. So to do this, 0 minus 20 is negative 20, obviously, divided by 17. Negative 1.1765. Negative 1.1765. I'm going to double check that I wrote that down right. Yep. All right, so what this means is that if the z-score is below that, then that means the difference is negative. And that means Tom did better. You know, sometimes drawing a little picture might help. I know I'm kind of cramming space on here, but, you know, here's my difference. I expect a difference of 20. And wherever 0 falls, that's the cutoff, right? Because if they get a 0, if the difference is 0, then that means they're tied. George didn't do better, Tom didn't do better, they're tied. So anything above 0 is when George did better, like he's supposed to. Anything below, maybe I should use a different color, anything below 0 is where there's a negative difference. And that's where Tom does better. So that's what we're trying to find. So I'm trying to find the probability that the difference is less than 0 because less than 0 is a negative number, which means Tom did better, which is equivalent to find the probability that a z-score is less than negative 1.1765, which is equal to, using the normal CDF on my calculator, and I'm going to go from negative infinity way down low to negative 1.1765 with a mean of 0, standard deviation of 1 for the generic normal model. All right, so here I go. Second VARS, normal CDF, and let's see here. I'm going to start at negative 99. That's really, really low. And I'm going to go to the negative 1.1765 z-score that's represented by a difference of 0. And I get a probability of 0.1197. So not unlikely at all. I want to squeeze it at 0.1197. So in fact, it would not be significant. It would not be weird. It would not be unlikely if Tom did better. In fact, it happens about 12% of the time. About 12% of the time, Tom is going to do better than George. And that's just because their scores deviate. Now, that does mean the other roughly 88% of the time, George is going to do better. Well, duh. George should do better because his score is typically 20 points higher than Tom. All right, this is a very common AP question. It's one that really kind of makes you think. A, you have to remember how to combine random variables. And B, you have to really have this strong understanding of why 0 is so important. Because below 0 is a negative difference, Tom did better. Above 0, positive difference, George did better. All right, guys, that's it for this video. This is finally done with topic 5.2 over the normal distribution. There is a lot to it, but it's super, super important that you understand it all. And I'll see you guys in the next video when we do topic 5.3.